So far, we've been looking at probability distributions, and now I want to move into statistics and finding things like the average of a set of numbers rather than a distribution. And before I start, I want to look at some symbols and notations that we're going to use. I'm going to let capital N be my population size, little n be my sample size, and xi represent my variables and my data values. To start with, I'm going to look at the population average. This is denoted by the letter mu. And we have that mu is equal to 1 over capital N of the summation from I equal to 1 to capital N of xi. What this tells me is that I need to add up all of my data values and then divide by the number of things I have. So exactly what people know the average to be. And this can also be called the mean or the expected value. The sample average, the average of a sample, is denoted by x bar. And just like for the population average, we need to add up the values and divide by the number of things. And this is also known as the sample mean. So let's look at some examples. Let's suppose a company of 10,000 employees initiates an employee productivity study in which the productivity of each employee is rated on a scale from 1 to 5. We know that 300 of the employees are rated 1, 700 are rated 2, 4,000 are rated 3, 4,000 are rated 4, and 1,000 are rated 5. And we want to find the population mean. Well, we know we have 10,000 total employees, so we need to divide by 10,000. We know we have 300 that scored 1, so 300 times 1. 700 scored 2. 4,000 scored 3. 4,000 scored 4. And 1,000 scored a 5. So now we just need to work this out. So if I work out this part in parentheses, I get 34,700. Dividing by 10,000 then gives me that my population mean is 3.47. Next, let's say we have a pilot study into the degree of employee satisfaction at work that interviews 10 randomly selected employees from the company. The productivity ratings of those 10 selected employees are listed here, and I want to find the sample mean. Well, I know I need to add these values up, 2 plus 3 plus 3, plus 4 plus 4 plus 4 plus 4, plus 5 plus 5, all over the total number of things, which is 10. If I add these up, I get 37 over 10. So here my sample mean is 3.7. Finally, I want to use R to obtain 5 samples of size 10 from the population of 10,000 employees and find the sample mean of each. So I'm going to move over to RStudio and look at how to obtain a random sample of size 10 and calculate the mean using RStudio. Here I have my RStudio, and I need to start by setting up the population. I'm going to do that by denoting a vector by x, and this vector has 300 values that are 1, since 300 employees scored a 1. There's 702, since there were 700 people who scored a 2. There are 4,000 3s, 4,000 4s, and 1,000 5s. I'm then going to let y be equal to a sample. The sample is going to come from this vector, and it's going to be of size 10. And I'm going to use a semicolon since I don't need to know what the actual vector looks like. And I'm then going to calculate the mean of y, the mean of that sample. If I run this, I can see that I get a sample mean of 3.4. And I wanted to get 5 different samples and their means. A second sample gives me a mean of 3.5. A third sample gives me a mean of 3.6. A fourth sample gives me a mean of 3.4 again. And a fifth sample gives me another mean of 3.5. So these are not all the same, which they shouldn't be. Means will vary depending on the sample that we have obtained. No sample is perfect. No sample is going to be exactly the same as the population. but they are relatively close for what we found to be the population mean.